Hello and welcome to CPP. This is the part 2 of the video series Introduction to GUI Programming with C++ and Qt 5. The first step is to open the project that we created last time. We added some files into the resource. We've designed the main window. We've created another UI form, another UI class called notes list widget. I showed you how to use it inside the main window. I want to do a small adjustment in the main window. This layout, I want to set the spacing to 0. I want these buttons closer together. We will do small adjustments in the GUI as we go. First thing that I want to do in this video, besides that small adjustment, it is open up the nodes.pro, and you want to go to the line that says config plus equals C++11. What I want to do is change the 11 into 17. Basically, this tells the compiler which C++ standard to use. We want to use C++ 17 because I'm gonna use some features from C++ 17. You're gonna see what I mean by that later on. If you don't have a C++ 17 compiler, I strongly suggest you update your compiler. But even if you can't do that, you can still go ahead and use C++ 11. I'm gonna talk about those features that I use from C++ 17, and you will manage to get them working. That being done, the first thing that we want to do after that is run QMake. QMake will regenerate all the make files and everything that is needed to build the actual project. Let's go ahead and add the code for the functionality. So what we need first is add a struct that's gonna hold our data. Add the new. We want the C++ option, and we want a C++ header file. Let's call this note.h. Next and finish. I use Pragma once instead of those if and defs. This is going to be a small structure that's going to hold our data. The struct is going to be called note, and it's going to have a few fields. It's going to have an int, which is going to be the ID of the note, and it's going to have two Q strings, which is going to be the title and the content, and it's going to have a Q datetime, which is going to be the last modified. Let's go ahead and include and let's go ahead and add the properties into our struct. Let's go ahead and add another class to our project. This class is going to be called Notes Manager, and it's going to hold the notes collection, and it's going to be like a business logic for our application. All right. I know what you're thinking of each time when you say something like that, like a class, it needs to do that and some other thing. That's not really good, and I agree with you. But I'm doing this to keep the structure of the application a little bit more simpler. So this means that the code in this class is going to be a little bit more complicated, and I'm going to leave this as an exercise to you to split this class into two classes. One class that's going to handle the notes collection, and it's just going to handle whatever is needed to be done inside that notes collection. and one other class to do the business logic, so to speak. Remember that what I'm doing here is not necessarily the best thing to do, but yeah, I want to keep the structure of the project a little bit more simpler, and this could be something like a homework if you want to do it yourself. So let's go ahead and add the C++ class. Let's call it Nodes Manager. The base class will be a Q object. We want this class to be able to send signals when some things happen. This class is going to hold the nodes collection. And as I said, I'm doing something that is not the most recommended way. I'm going to combine nodes collection and the business logic. As I previously said, this is an exercise for you to split these classes into classes. One class could be named something like nodes collection, and the other class could be simply manager or nodes manager or business logic or whatever you want. The nodes collection one will just manage the collection, and the nodes manager will just manage the business logic. Let's add a destructor to this. We're going to need one. And let's create the function prototype for the functionality that we need. So we need a function to create a new node. We need a function to remove node. And this function will need to take the ID as a parameter. We will need to know which node do you want to remove. We'll have a function to rename a node. This is going to be one parameter for the ID of the node that you want to rename, and const QString reference for the new name, or this could be new title as we refer to it. So yeah, let's go ahead and title. Now we need some ways to access. We need a method to access a node. We need to return a node, a constant node reference from this class. So let's go ahead and add the prototype for that. This is going to return a const node. It's going to a const node reference, and it's going to be a const function. It's not going to change any internal data. We will need to add some forward declaration for the struct node. Let's go ahead and talk about the internal data structure that I'm going to use. So I'm going to use a standard unordered map. Let's go ahead and include that. Unordered map. Let's call these nodes. Unordered map stores key value pairs. So our key will be the ID of the node. This is going to be the key. I'm using unordered map because in unordered map, looking up for a key is very, very fast. So let's go ahead and call that. I want an unordered map of int. And let's see what we want to do. If you will split this into two parts, this is gonna be the structure that you want. You want an unordered map of int to a node. But we are using We are using this as both our data and a little bit of business logic into it. We're not going to hold directly the node as a value in here. We're going to hold a pair of node and something called a QText document. Now, why I'm doing this with a QText document, why I'm putting this into a business logic? Well, basically to teach you, to show you a little bit that even something as simple as a text edit has some backend, has some underlying data structure that holds the actual data. And it also works out a little bit better. We are gonna keep switching the text in the text edit as the user switches to another node. And by holding the QText, a separate QText document, instead of just replacing the text in the text edit, it's going to give us some advantages. Like, for example, each node will have its own undo redo stack. Those won't be lost when you change from one node to another, or you won't undo to the text that a previous node had. Basically, we will not have to manage that undo and redo stuff for each different node if we do it this way. Here I'm going to use a pair of node and a pointer to a QText document. So let's go ahead and include and do the necessary includes. So I want to include utility for a pair. The QText document, I want to manage the memory of it into this class, but I don't want to manage it manually. So I'm going to use a unique pointer. So let's go ahead and include memory too. And let's go ahead and forward declare our classes. So QText document. And to manage the changes from each document, I'm going to use a QSignal mapper. So let's go ahead and forward declare that too. This is a pair. This is holding pairs of ID and another pair. So standard pair. That pair would be of node, our struct, this node, and standard unique pointer of a QText document. This is a little bit of a complicated structure. You can take your time a little bit to wrap your head around it. So it's a structure that holds pairs of keys and another pair. One part of the second part of the first pair is going to be a node, and the other one is going to be a unique pointer to a QText document. It can look complicated in the beginning, but it's not that complicated. Let's go ahead and create our accessors for the rest of the stuff. So we're going to need a method to get to the text document because we want to set this text document into our text edit as a backend. We're going to need to return a row pointer. Qt doesn't use the standard unique pointer, but it's good for us because the text edit will not take ownership of the memory of the QText document. We can manage that separately. Let's call this node to document. And again, as a parameter, we want the ID of the node for which we want the document. Again, this is going to be a constant function. We want a function that's going to return a list of all nodes. So we could do this. We can return a vector of node and call this node collection. This doesn't take parameters because this returns all the nodes. Let's go ahead and include vector too. I'm going to show you how to create a vector of reference wrapper. So basically you couldn't do a vector of references in C++. You can't do that because standard says that the reference is not required to occupy any memory. Reference is something like just another name for an object. Can't do that in C++, but what you can do is use the standard reference wrapper. And yeah, let's go ahead and do that. This is what we are going to return. So basically we are going to return from this function a vector of references to nodes that are in our collection. Let's go ahead and create a function that's gonna return the number of nodes that we have in our collection. Again, this doesn't have parameters and returns a size t. A size t is usually defined something like unsigned long or something like that. It's a type def for whatever the standard containers use as their size type. It's usually unsigned long, something like that. It depends on your compiler implementation, and I think it depends even if you're compiling for 32-bit or 64-bit. It's the standard size for the containers. We're gonna need two signals. One is gonna be new node created. We want to notify whoever is interested that we created another node. And the other one is gonna be node content changed. And again, it's gonna send as a parameter the ID of the node. For this signal, we're gonna need the signal mapper that I talked a little bit earlier. Well, why do we need that? What's the problem here? We want this signal to specify the ID of the node that changed. But the text document doesn't have any mapping, doesn't know that a node exists, doesn't know what a node is, and its changed signal sends no parameters. So to fix that, we're going to use a signal mapper to map each text document to an ID of a node. That way we have a relationship. A text document signal is emitted. We know how to map that signal, or QSignal mapper will automatically map that signal with an ID that we set for that specific text document. QSignal mapper pointer map changed node ID or map changed signal node ID. We're gonna put it to null pointer. We will also need a couple of private functions. We need a slot that is gonna be called by the signal mapper with each content changed mapped to an ID. So let's go ahead and create that. Gonna be a void on node content changed. But unlike the content changed from the QText document, this is gonna tell us the ID of the node that changed. Also, we're gonna add this function will not be implemented. I don't think we have time to implement that in this video, but let's just add those. Basically, we want to write and read nodes to an XML file. That's going to be implemented in a next video. Go ahead and implement all those functionality. Let's start with the includes that we need. We need to include node.h. We're gonna need to include QText document. and we're gonna need to include QSignal mapper. Let's start with the constructor. First thing that we need to do is we need to initialize the signal mapper, and we're gonna pass this as a parent. So this means that our nodes manager will be the parent of the QSignal mapper, and it's gonna delete the QSignal mapper whenever it gets deleted or whenever it gets out of scope, because we are gonna allocate this on a stack in the main function. We will not have a memory leak. What we need to do after that is we need to connect. This connect statement will have more sense when I'll explain it later on, after I'm doing the first connection, the connection of the text edits signals to the mapper. This is basically the second part of the connection. This is the part where the mapper sends the signal to our slot, to our node manager on node content changed. Anyway, I'm gonna go back to this a little bit. Go ahead and connect the signal from QSignal signal mapper mapped int to this. In this connection, basically we connect the mapped int to our on node content changed. Our function, our slot on node content changed is actually this one, and it takes the ID, and this will be called with the right ID each time a QText document will get modified. First step is going to be this text document. It emits the signal content changed. That goes to the signal mapper, and the signal mapper maps, okay, this text document is mapped to the ID 1, let's say, and ID 1 is node 1. This is how the workflow goes. So we basically did only the second part for now. Whenever we will create a QText document, oh, by the way, I forgot about that. We need a function to create a QText document to do all the initialization. So let's go ahead and add that to the function that returns a unique pointer to a QText document, and we'll call it create new text document. This is gonna take a const node reference. Basically, in this function, when we will create the text document, we will connect the text document to the QSignal mapper, and we're gonna set the mapping for that same document to be mapped to the ID of the node. For each node, we will have a QText document. It's this pair here. Each node corresponds, for each node, a QText document corresponds to it. And we are going to map the signal using a QSignal mapper for each text document to correspond to the ID of the node. It's a pretty useful thing to know, this QSignal mapper. So yeah, I hope I explained it well enough so you'll understand it. So let's add the definition for this too. And let's go ahead and continue our implementation. We set up the mapper. Now we want to read the nodes. Again, this read nodes, as I said, is not gonna be implemented in this video. We are gonna implement it in the next one maybe. I still have to plan this in one of the next two videos. So we want to check the size. If it's equals to 0, we want to create a new node. This is the part of the business logic that I talked about earlier, same as the signal mapper. If you want to split this into two separate classes, the signal mapper and this code like this that checks the size, and if it's 0, that goes to the nodes manager, and the rest of the code goes to the nodes collection. You can still keep it like this, but I just want to kind of teach you a little bit. Maybe I will do the split in a future video, but I'm not really sure about that. Maybe we'll see. I'll leave it as an exercise for you to make the code a little bit more solid. So in the destructor, we will just dump the nodes into the XML file in the future. We want to create a new node. To create a new node, we need a function to get us an ID that's gonna be like pseudo unique. We are not gonna go and generate a UID. This is gonna be a simple function. Let's declare it here. An int get next node ID. And we will implement it here in this CPP because we don't need this function anywhere else. This is gonna be just a static int id equals 0, and we're gonna return plus plus id. We got the new ID. Now I'm gonna use the C++. Remember in the beginning of the video I talked about the C++ 17 feature. I'm gonna use a feature called structured bindings. So what structured bindings allow us to do is name things that are basically returned in this case from a pair, but we could name stuff from some other collections. I don't know exactly if this feature works for other stuff like arrays. Tuples should work. Maybe vectors. I don't know exactly the limitations, but for this, we are going to use it for a pair. We want to return the nodes with the ID, and we want basically for that pair, we want to take it by reference, and we want to call the first part of that pair that is returned, we want to call node, and the second we want to call text document. Basically, this allows us to write a little bit more cleaner code instead of writing first and second, because this would be a pair, and we should give a name for the pair and then call it like pair first, pair second all the time. This is more clear because we write node.id equals id, and it allows us to initialize it way better. Node title will be like new node. Node dot last modified will be q date time current date time. This was modified it right now, and text document will be create text document, and we want to send a note as a parameter. And after we done that, we emit new node created, and we set the ID. This could totally be omitted. This is perfectly fine like this, but I usually like to keep it there just to remember next time I'm reading the code, or whenever somebody else reads my code, to see that this is a signal that we are emitting here. This is not just a function call. We emit a signal, and code somewhere else might get called if it's connected to our signal. To remove the node, we do nodes dot erase of the ID, and then we do another check. If nodes is empty, create new node. Rename node. We are not gonna implement this. We're gonna leave a to do. To get rid of the unused parameter, we can use QUnused of ID and QUnused of title until we implement the method. Rename node will be a feature that we'll implement it in a future video. I'm not sure if it's going to be the next one or the one after the next. So here you can do return nodes, and you might be tempted to use this dot first, but you will get an error. Basically, you get an error because this operator is not constant. We specify that this function is constant, so this function cannot change the collection. And this operator, if the ID is not found inside the nodes, it will create a new item with the same ID. So what we want here to do is use the at function, and the at is a constant. So I think that this will throw an exception if so yeah, out of range. It throws an exception if the container does not have an element with the specified key. This could throw an exception. We basically will just make sure that our program never reaches into that case. We need to return a QText document from our nodes. So to do that, we're gonna use the find function. So we're gonna set auto found nodes.find ID. And what this does is this will find the element with the ID in the nodes. So found, it will be an iterator. So to check if this was found, we have to check found is different than nodes.end. Basically find, if it cannot find the element with a key that we send as a parameter, it will return nodes.end, which is an element one past the last element in the collection. So this is an invalid element. It's something that we cannot dereference, but it's used as a way to tell you that okay, we couldn't find the item. We want to make sure that found, the iterator that was returned by find, is different than the end, and only in that case use it. So in that case, we want to return found arrow second dot second. So what this means, found, if we dereference is, found is an iterator, but it's an iterator to a pair. It's an iterator to a pair that contains the first element is an ID, is an int, and the second element is another pair. So we access the second element, which is the pair, and from the second element, we access the second again because we want the unique pointer to our QText document. And from that, we don't want to return the unique pointer because we don't want to get rid of it. We still want to manage the memory for it. So we use get from the unique pointer. We use get member function to get access to the row pointer that it's stored in the unique pointer. And if found is not different than the end, we will return null pointer. Return null pointer. This function is gonna return the collection of the references to nodes, but it's gonna also update the nodes content. I'm not gonna update the nodes content each time the text document changes. I'm not gonna just, even though QString is copy on write, so no copy is made actually, or it might be some specific cases where copiers are made, but we are not going to update the content of our node struct each time the user presses a key in a text edit. But what I'm going to do, I'm going to update it into this function. When I create the list of references to all nodes, because this function is going to be used for write all nodes to the XML files or read all nodes for the collection. Like for the main window in the constructor, we will eventually call this to initialize the list that we read from the file in the beginning or something like that. And for those cases, we also need the content of the nodes. We don't only need the nodes ID. So yeah, let's go ahead and declare a vector of standard reference wrapper of node. I don't know why this happened here. It shouldn't be. So let's call this out. And we're gonna go ahead and loop through our old collection, auto reference. Let's call this I. So we're gonna use again the same feature that I talked about previously, structured bindings. Again, for the same reason, to have the code be more readable. We want to do the update, so node content will be text document, and here you have a few options to use HTML. This is not really full HTML, it's just a subset. It's basically more like rich text. In the Qt documentation you can find the subset and you can find all the stuff. We're not going to use that. We're going to use plain text. But if you want to create to update this project and create a little bit more complicated one, you know, that has formatting and coloring for the text and different kind of rich text, you can use to HTML. And we want to push back this in out. And in the end, we return not out, note. Count will be pretty simple. We return dot size. On node content changed, what we want to do is we want to update the time when the node was modified. So we want nodes dot at id and last modified, and we want to set it to Qt date time, current date time. As I said earlier, we are not going to update each time a node change. We are not going to copy the text from the QText document to the node. So we are not going to do that here. So we just emit node content changed. We emit the signal with the ID. So we were just gonna let the main window know that it needs to update or it needs to do whatever it needs to do when the content changed. And I'm gonna just put a to do here. We will be implemented it as I said in a later video. We need to create an actual text document, unique pointer. So we will use the make unique of Q text document, and we're gonna pass the content of the node to the constructor. Basically, this argument here is not an argument for or it's an argument for make unique, but the make unique will pass this argument to the type constructor. So we are going to construct a unique pointer to a QText document, and that text document we're going to have the content from the node. We want to connect the signal from that text document. So we want text document. And again, text document is a unique pointer. We can't use unique pointer for the connect. So we need to get the raw pointer. Text document, contents changed. As the receiver, we want the map, and we want to connect it to QSignal mapper map function that doesn't take any parameters. We can't really do that because map has two overloads. To go around that, there is a feature in Qt. It's called Q overload, and you want the function takes no parameters, and you want to pass that the function pointer you want to pass it to Q overload, and this will return the function pointer to the right overload of map. after that, we want the map. We want to set mapping in between text document dot get. We want the row pointer to the mapper also, and we want to map that to a node ID. Basically, we map the row pointer to the content that we want the mapper to send to our slot. In our case, that's an int, which is the ID of the node. This is what we connected here. We connected mapped int to our own slot. Our own slot is this one. So whenever a text document will be changed, the contents change of that text document will go to the signal mapper, and the signal mapper will then emit its own signal mapped int, which is going to be connected to our own node content changed. And here the mapped int will be the ID of the node. So we just access the ID into our own nodes data structure. We set that it was modified now, and then we emit our signal and pass the ID forward. Let's go ahead and add functionality into the node list widget class. So as you already know, this class manages the UI list of nodes. We're gonna need forward declaration for a few things. We're gonna need to declare our node. And we're gonna need to forward declare QList widget item. This class is gonna need a few member functions. Let's go ahead and write the declarations for those. We're gonna need a function to add node. This will gonna take a constant node reference. The removal of a node can't happen from anywhere outside of the UI. And the UI, from whatever place we will remove the node, is going to remove the current node, the selected node. So the remove node is not going to take any ID or something, at least not yet. So the remove will be remove current node, and is not going to take any parameter. We're going to have a function to update current node, and this is going to take a constant node reference, node with new information. It could be like a new title when we will add the functionality to rename nodes, or it could be that the node was updated and to display again. This is again for the future, to display the date when the node was modified. What we will do right now in this video with this function is just move the node. If it's not the node in the top of the list, we will move it to top. This is going to be a little bit tricky. This is where we get into where a model view approach would be a little bit better if you want to move stuff around and do things like that. Model view approach is a little bit better than using an item based, but I'm going to show you how to go a little bit around that for now, and maybe we will add in a future video model view approach for this situation too. We're going to need another function to get the current node ID. This will return the current node ID, the ID of the selected node. Let's go ahead and add signals. We have selected node changed, and it's gonna have a single parameter, which is gonna be the ID of the node, the selected node. So let's go ahead and add some private functionality. We're gonna need a void on item selection changed that doesn't have any parameters. Basically, the list widget doesn't know anything about our nodes. It's kind of the same as it was previously in Nodes Manager, where the QText document doesn't know anything about our nodes. It doesn't have a clue that it's connected to a node, it represents a node. He don't care about anything. He can represent anything you want. We will connect the internal list widget to this slot, and in this slot we are going to emit the external signal with the ID of the current node. And main window will connect to this signal and do whatever it needs to do. We will get to that in a few minutes. We're gonna need a few helper function. We're gonna need one to move current item to top. This is gonna take a const node reference because in the next part we will add a custom widget for the item, and we're gonna need it's again the same thing that we have with the limitation of an item based approach that we choose. Basically, when we take an item out of the list and insert it in the top of the list, that's gonna do something that's not really what we want, and we will need to recreate something. But that's gonna be explained in a future video. And we're gonna need another function. Basically, it's still a function that's gonna have more value in the future. Now it's just a convenience. Now what we need to do in the constructor, we need to add a connect statement, and we want to connect the UI nodes list, the list widget from the UI. We could name this a little bit better. We could name it like nodes list. Let's do that. That's gonna be nodes list and view list widget item selection changed. We're gonna connect it with this list widget on item selection changed. We want to create a QList widget item. Specify that it's a pointer. New QList item. UI list. Insert item at position 0. Because we want to add the item to the beginning of the list to insert it in a position 0. And we call the function setup node item with the node that we get and the item. For the remove, we're gonna get the item, current item. It's gonna be UI list current item. If current item is different than null pointer, we want to delete current item. Also, yeah, we want to specify this. This is not really mandatory, but you can specify that it's a pointer. It's more clear for someone when someone is reading the code. So even if I remove that, the current item would still be a QList widget item pointer. I like to specify it. Make sure that when someone reads it, he knows that okay, this is gonna be a some type, whatever this returns, pointer. So it's clear that this current item is a pointer. The update is not gonna do much for now. We are just gonna move to the top if the item is not already to the top. We can ask current row. We're gonna use current row right now, and if that is different than 0, so if the current row is not 0, we're gonna use move current item to top. We're gonna pass in the node auto current item. Before I implement this, I want to go to the setup current item. Implement that first. We need to get some data from the current item, and I want to show you first how to put it in. Yeah, we need to include the node. We need to do when we set up node item is we need to set the text to be the node title. Then for the item, we need to set the data. And Qt has an enum which specify which role the data that we set into the item is gonna be. It can have multiple roles, but we are not gonna go that deeply into it. But it has that enum has a value called user role, and that's what we want to use to put in the data that we need the item to store. So we don't want this to be displayed anywhere. This is just going to be stored inside the item, and we can retrieve it later when we need it. That would be in the current node ID. And what we want to do as the setup, we want the nodes list to be set the current item. So we want an int, which is gonna be the ID, and it's gonna be, let's call it node ID. We want to get it from the current item, and we're gonna use the function called data, and this takes as a parameter the same thing that we put it. So we want user role, but we get an error if you use it just like that, and it says that QVariant to int no viable conversion. So this data doesn't really know what data we put in there. So actually this doesn't set the ID as an int, because we could have put a string or whatever. And Qt has something that well, nowadays even C++ can have it, standard variant. But anyway, Qt has a class called QVariant, and QVariant can store different kind of types, and this is basically what is stored in there. Even though when we set the data here, we passed an int, this int was wrapped around in a variant. This is what data returns. It returns a variant for whatever is set in the user role. So what we do is we use a member function of the variant called toInt. Now toInt, as you can see in the small notification there, takes a bool pointer. This bool will be set. It has a default value of no pointer, so if we don't pass anything, we basically ignore it. So we will not gonna pass anything, but I just want to explain you what that means. So that bool, if we send there a pointer to a bool, that boolean will be set to true or false if the conversion succeeded or not. So if that variant wasn't actually, like if someone modified here and set the node content instead of the ID, or the node last modified instead of the ID, that said something completely different and you forgot to update it when you read it, then this is gonna fail. And with that boolean, you know that you fail or not. So we are not gonna use it for now. We don't want to make this extremely long. On selection change, this is the slot that executes whenever the selection in the nodes list happen in the QList widget. So what we want to do in here, we want again to take the current item. Again, let's specify that we know it's a pointer. UI nodes list current item. We want to check if the current item is different than null pointer. Remember that you can use this syntax for a pointer. Pointer, if it's different than null pointer, will evaluate to true. So this is perfectly fine. This is the same basically like this one. So we can do it both ways. We have a pointer and we want to get the ID for the current node. This is just calling the function that we created previously. We get the ID if the current node is valid. If we have a current node, we will call the current node ID. Get the ID and then emit the signal selected node changed, and we're gonna pass the ID as a parameter. When we move the item Because of the limitation of QList widget, we can move an item to the top. We will have to basically remove the item and insert it back. So that will mean that the selection will change, and we will emit the signal again with the same ID as we did when the item got selected in the first place. So we don't want that. So Qt provides this functionality. It's called block signals. We can put block signals to true. This will make this class not send any signals at all. We want this to unblock it, and we want to set it to false in the end. Want to make sure that this doesn't remain with the signal block. This code like this usually is problematic, because if we have, by any chance, if we will have something that return statement, this will remain active, and after this is executed the first time, this class will not emit any signals at all. And this is not only with return. For example, if we have exceptions, it's the same thing. So what we want to make sure basically is the code in between these two lines does not throw exception or not use any return. So this is a little bit of tricky code. This is code that if you're in a company might not get past the code review. We're gonna leave it here. I'm just gonna tell you a little bit of how you do it, like a little bit of a pattern. So you could create a class that takes a pointer to a Q widget or a Q object if you want, and the class could be named something like signal blocker, and that class takes the pointer to a Q object, blocks the signals in the constructor, and in the class destructor you call block signal false for the object that you just take by pointer or reference. And then you will have something like object signal blocker that will take this, and this class in its constructor will take a Q object by pointer, and it will call block signals, and when this is going to get destructed, its Q object signal blocker destructor will call block signals with false. I'm not going to do this here just to keep the code simple, but I just wanted to tell you that. In our code here, we are pretty much safe because we only call Qt functionality, and Qt does not throw any exceptions. So we are safe, but this wouldn't be safe like in a long run. That's why I explained you why a thing like that it's pretty important. It's the same pattern like for the mutexes. In when we will get to multi-threading, if you didn't got into multi-threading already, when we will get there, I'll explain the pattern a little bit. It's very useful there too, because if you have a mutex that locks something and the mutex remained locked just because you throw away an exception, that's not good. So we use take item to get the item from the list, and we use the current row. Take item basically takes as a parameter takes the row in which the item is. So we're gonna use node list, and we're gonna use current row passed to the take item. That returns a pointer, an item. And what we want to do is reinsert that item into the position 0. And we will also call setup node item again. In this case, it's not really mandatory for now, but this will be good when we will have the other functionality. So I'm just gonna add this here. We have the main window. Again, we will start with adding a few forward declaration. Want a class nodes manager. We will depend on the class node manager, and we want a struct node. What we want to do is we want the main window to take a nodes manager by reference and store a reference to a nodes manager as a member, and we will take it by reference in the constructor. So let's go ahead and implement that first, and then we will go and do the implementation for the rest of the functionality. So whenever you have a member reference, what you need to do is you need to initialize this in this initialization after the constructor. You can't initialize it not after, before the constructor. You cannot initialize it in the constructor body because references needs to refer to something at all times. References are constant in this, are like a constant pointer. They cannot change to what they reference. You need to use the same functionality as here, and we'll go nodes manager, and it will be initialized with a reference that we get here. So before we go more into the main window, let's go ahead to main CPP. So we need to include nodes manager, and then what we want to do is we want to create an instance of the nodes manager. Let's call it manager, and we pass a reference to it to the main window, and then the rest of the code remains the same. But we're gonna go and set a few attributes for the QApplication. So these attributes that I am gonna set right now, we need to set them before we create the QApplication object, which is this A. Let's go ahead and set it. QApplication set attribute, and for the attribute we want AA use IDPI pixmap, and we want to set it to true. Because we have the icons as a SVG, we want Qt to use high DPI pixmap. So basically render the SVG at a higher resolution. And we want to set the attribute of Qt AA enable high DPI scaling also to true. All right, we are all set in the main CPP. Let's go back to the main window. This will mostly be handles for the events of the nodes manager and for the events in the nodes list widget. Signals from UI, from the design of main window. We're gonna need to handle nodes manager signals. We're gonna need handles for that, and we're gonna need to handle nodes list widget signals. So let's go ahead and add signals. So nodes manager has two signals. It has a signal new node created. This slot is gonna be a void on new node created. This is gonna take an int as a parameter because that signal passes an int. So we have on node content changed, again with an int as a parameter because that signal passes an int. So let's go ahead to add the functionality for handlers for node list widget. We have on selected, node changed. Again, it's gonna take an int ID as a parameter because that signal sends us the ID. Void remove, or let's say on remove node is gonna take an ID. We will need to code a little bit more private functionality. We will make a function add node to list, which is gonna take a constant node reference node. We're gonna have a remove node that's gonna take an ID, and we will have a private function in it. This is gonna read the nodes in the beginning. This is gonna be called in a constructor, and it's gonna read the default nodes. So for now, we will not have anything except the one node that's gonna be created. But when we will save the nodes, basically in this function, we will read it and create the item in the list in the UI. based on the notes that the notes manager read from the file. So let's go ahead and write the include. We need to include the notes manager. We need to include note. We need to include list widget. And for later on, we will need to include Q message box. This is gonna be needed when we want to remove the note. We want to ask the user, are you sure you want to remove the note? So that's why we include a message box. We want to call the make connection and we want to call the init function. As I said, the init function will basically take the nodes from the nodes manager and do the thing in the UI. This is the button clicked. All we want to do here is call nodes manager and create new node. This will do all the stuff automatically because this will emit the signal that a new node has been created. We're gonna get the signal here on the new node created and we're gonna add it to the list afterwards. So for the button click, all we need to do is call this function. For the remove, we're gonna call our remove node and we need to pass the ID. So we're gonna get the ID from the nodes list widget, current node ID. So on new node created, here we need to add the node to the list. We get auto reference node, or actually we can just call it add node to list and then nodes manager dot node and ID. This just passes whatever this returns. So we get the node from the nodes manager, the node with the ID, and then we pass it to the function that's gonna add it to the list. So on node contents changed, what we want to do is we want to call the UI nodes list widget, and we want to call update current node. And again, we get the node from the nodes manager dot node of the ID. So again, we get a node reference to the node that has changed, and we call update current node in the nodes list widget. On selected node changed, we need to get a document auto pointer document from the nodes manager node document of ID. We don't expect this to ever be null, but we check anyway. And then we want text edit and we want set document. So basically we take the document from the nodes manager. We take the qtext document pointer. We check if it's not null. This is, as I said, this is not mandatory because this is not gonna come with an ID that is not in our collection. But we check it anyway. It's better to check the pointers. And we pass it on to the text edit. Basically, this is how we say the text to the text edit. Hey, here's your backend stuff. Use this, and the text edit will update the text if it's any text in here, or if the document is empty. When the user will write something in a text edit, it will be saved in the document. So now this is optional, but what I want to do is I want to set the cursor to the end of the document when we change it. I'm gonna take the cursor from the text edit. I want to take the text cursor from the text edit. I want cursor move position to text cursor. Move the position to the end and then set it back to the text edit. Text edit set text cursor. These lines of code are optional. You don't have to do this. I just wanted to show you how to do this if you need it, and I think that it's a good idea when you change from one node to another, the cursor to be at the end. again, if you want something else, if you wanted to put it in the beginning, maybe he wants to read the note from the start, maybe he wants to add a note. This is just me telling you how you would do something like that. But it depends. It's up to you. How do you want to code it? It's not mandatory. So on remove note, this is the same remove note, and we pass back to the ID. So the add notes to the list is simple. We get the pointer to the note list widget, and we call add note, and we pass in the note. Now to the remove note, it's gonna be a little bit more tricky. We want to take the title of the current node. We do that by taking it from the node manager, and we call node. We pass in the ID, and we go title. So basically, for whatever reference this function returns, we call title. Now what we want to do with the title is we want to display it in a message box and ask the user if they want to delete the node. So let's go for an auto and show a message box. This is gonna be the button that the user pressed. So I'm gonna say pressed button, and I'm gonna show a message box. The message box is gonna be one of the standard Q message box. It's called information. We're gonna use this as a parent. We're gonna set the title, which is gonna be remove note question mark. Let's not go that long. Press a new line, and we are gonna use a Q string here. Are you sure you want to remove? And here we want to insert, before the question mark, we want to insert the node title. So to do that, we do %0. Basically, %0 means that this will be replaced with whatever argument we pass to this with the first argument. So to pass an argument, we call the arg, and we pass in node title. All right, and now we need to specify which. This is basically a way to format strings in with Qt. C++ standard library will have something a little bit similar in C++ 20. We need to specify the buttons that the message box will have. So it will have message box yes. This is gonna mean that it has a yes button, and we need a no button. And we're gonna set this by combining the bits. The parameter each bit represents a button. So we go again, message box no. The last parameter it's the default button. The default button we want it to be no. Again, message box no. And that's it. We want to check if the pressed button is equal to message box yes. So if the user pressed yes, so this function returns a button, returns the button that the user pressed in between these two buttons that we said that the message box can have. If the button pressed yes, then we need first we need to check if the count of the nodes is equal to 1, or if we're about to delete the last node, then we need to set the text edit to not have, or to basically remove the document from the text edit, because we are going to delete the document. It takes a little bit of a time until the next node is created, and that document will be set into the text edit. So in that split second there, the text edit will basically refer to a text document that was deleted, and we don't want that. So we want set document, and we're gonna just pass null pointer. So this is just a specific case to handle in our UI. And we want nodes list widget, remove current node, and nodes here, remove node with the ID. So basically we remove the node from the UI list, and we say the nodes manager to remove the node from the backend. This is the only weird piece of code. It's just a safety net, because when this executes, this will delete the text document, and we don't want the text edit to have access to a document that was deleted. This is a problem only when we remove the last one, because the nodes list widget, when it removes its node, is gonna change the document if it has another valid node. So that's why this is a problem only when we remove the last one. If this has another node, it's no problem at all, because another node will just get selected and the text document will be changed before we actually delete it here, or it automatically gets deleted here because the unique pointer is out of scope. For the init, we have to read all the nodes list. Let's get auto nodes list, nodes manager, collection, nodes node collection. There should be nodes collection, I guess, but yeah, well, it's a typo. For now, we will go with it. So we need to get that list, and remember the unordered map doesn't have an order, it's unordered. So we will need to sort this collection. So for that we use standard sort. Okay, we need another include to use it. Let's include algorithm. We include algorithm for the standard sort. So we want to sort nodes list dot from the begin, nodes list dot end, and we need to provide something called predicate. A predicate is a function that we pass in to a standard algorithm, or it doesn't have to be standard, to some algorithm to do some stuff for us. So in this case, we want to pass in a comparison function that can compare two nodes. Yeah, we could do this in different ways, but we are going to use a lambda for this right now. So we need a lambda. That lambda will take two const node reference. Let's call it left, the first, and another const node reference right. This is basically just a comparison function. So we take two nodes and we return. We want to compare this by something. So what can we compare them of? We want to compare the last modified property of each of these items. So let's go left. Last modified is smaller than right last modified, and that's our return. So this way now we have nodes list sorted, and we can just go ahead and iterate over it. Auto node inside nodes list, and add node to list. This function, if you remember, we just implemented it. This where is it? Yeah, this basically just adds each node into the node list widget. We don't have to do anything else because we already have it. Nodes manager already has the items. For now, as I said, this is just for when we will have the storage. In a separate video, we will store the nodes to an XML file. We need to connect all the dots. So we need to connect nodes manager the signal from the nodes manager. It's nodes manager node created. We want to connect it with this in window on new node created. We want to connect again nodes manager node content changed. This on nodes content changed, and we want to connect nodes list widget selected node changed with this in window selected or on selected node change. We have hopefully we have an application. The nodes will all be called new node because we didn't implement the rename functionality. Okay, we also have an error. I forgot to return a value from our function. So yeah, here it's just return text document. And hopefully I didn't make any other mistakes. So yeah, we have the application running. All the nodes will be called new node. So let's test this. If we change this node, if we change the text on it, it should move to the beginning of the list. So these two should be swapped. Let's go ahead and do that. Okay, that works also. Let's create another node. All right, let's say that we want to remove this one. So the default button is no. No, we don't. Or do we? Yeah, let's do. Let's say we've learned C++. Let's say we've learned GUI programming too. And all we need to do is create cool applications. So that's it for this video. Hope you learned something. In the next one, we will implement a cooler widget to display here. And we will implement the rename functionality. See you in the next one. Hope you learned something. Bye bye.